So my name's Adam Murray. I work for a small startup company in Sydney, Australia called Tickaboo, and we have a software product that has quite an extensive REST API. And so about 2 years ago, I came to this conference and I saw in one of the lightning demos, one of the Microsoft guys did a demonstration of PS Swagger, and I just went, wow, look at this. I can point at my API and I can generate my module without having to handcraft it. Anyhow, time goes on. Came to the conference last year, and I was having a chat to Jeffrey Snover, and he said, yeah, PS Swagger is not really going anywhere now. It's going to be AutoRest. And AutoRest is a tool that Microsoft uses to automatically generate client libraries for a number of languages, and specifically around Azure and some of the other management tooling. So I'll go, oh, okay, let's see what happens with AutoRest. And so it was coming to around November, and that's when the call for proposals comes for this conference. And I was sitting there and I was going, I need a new idea. I need a new idea. And I saw this tweet, and it was from Fear the Cowboy. So if you're not following Fear the Cowboy, you should be, because he's the lead developer on AutoRest. And he said there's a very early beta version of the PowerShell extension for AutoRest available. So I went, yes, here we go, let's put a proposal in. Anyhow, so that's where we are today. PowerShell plus AutoRest plus Swagger equals instant modules. So what are we going to cover? So we'll have a look at AutoRest and an overview just of how it works. We'll dig into a little bit details around OpenAPI because that's so critical to how AutoRest generates the modules. We'll do a very simple demo, and it's actually based on some of the examples that are available in the repo. And then we'll look at a real-life example. So we took our app and we pointed AutoRest at our API spec and generated a module. And I'll talk around some of the issues and what we had to deal with. And some of those issues were around authentication. And then finally, we'll look at how you can use AutoRest to generate client libraries or SDKs for other languages. So this is the basic flow. What do we got here? So AutoRest sort of takes a feed from an OpenAPI, which was formerly known as Swagger. And what happened there was Swagger actually donated the specification to the OpenAPI initiative. And this happened about 3 years ago, and that led to the renaming. So prior to that, it was all known as Swagger, and you would have heard people talk about Swagger API. Today, Swagger still provides an open source tool sets. So they've got a thing called Swagger UI. I think they've got Swagger CodeGen. There's a few other tools, and we'll have a look at Swagger UI as part of this demonstration. So we've got AutoRest up there. So it takes the OpenAPI spec that we'll have a look at shortly. It then generates a whole lot of scaffolding, C# code, PowerShell scripts, essentially all the sort of stuff that you'd need to create the PowerShell module. Because of the C# code, we actually need to compile it, and that generates a DLL that is used as part of the final PowerShell module. So an OpenAPI document or specification is a way of documenting REST APIs. So REST APIs can be, are becoming quite prolific for interacting or integrating between systems. So generally, underlying most of the things that you're interacting with on the web will be a REST API, even if you're using an SDK that wraps it. So for example, when you're calling the Azure Commandlets, underneath it is actually making REST calls to the REST API that is Azure. So REST APIs, in a way, define the functions and the objects that you're going to be dealing with, or methods and the objects. So if you're doing something like, say, get service, that's calling a function service. It takes a parameter, it could take a parameter which might be service name, and then the output is going to be of a type process info or a service info, whatever the output type is. So that is all documented within the API. The other thing that with REST APIs is they mirror quite closely to the HTTP methods. So you've got a get, a put, a post, and a delete are the four most common HTTP methods that are used. And they marry very closely to what we know in PowerShell. So get is get, very simple. A put is like a set. A post is like a new, and a delete is like remove. So we'll be mainly working with get today because we're working on some very basic examples to start with. So AutoRest itself is the code generator. It reads that spec. That spec doesn't have to touch the actual website or the API at all. It just needs that document that's defining what that API looks like. It can generate, well, as I said, for multiple languages, and it creates a whole series of folders, scripts, C#, and we'll see that shortly. The C# gets compiled, and finally we have our PowerShell module that we can then use. Okay, I want to jump to a couple of links, so just give me a moment. I'll launch these. So this is a website called API's Guru, and it's essentially, it has another set of tooling to deal with OpenAPI specs. But as part of that, they have a collection of APIs that are available. So you can go and browse this. You might see an API that you want to use, and it'll have an OpenAPI Swagger spec that you could download and possibly compile into a module using AutoRest. So I'll just browse through this because there's quite a few. So a lot of AWS for the interacting with AWS. Some random ones. Oh, look at that. Australian Government Tax Office. Oof. Stay away from that. Then we've got Microsoft. So once again, a lot of these are to interact with Azure. And some more random ones further down here. Oh, wow, quite a lot of them. Then Google. Seeing a bit of a theme here, 3 big players out there. And then finally, the one that I'm after, and that we're going to do our initial demonstrations against, is this XKCD. So they give you a link to the specifications. So we're going to jump into the YAML spec first. Is that big enough for people? Okay, great. So we're going to cover off a few of the items. So if we're looking, what have we got up here? So this is the version of the OpenAPI spec that you're talking to. So initially, over the last couple of years, version 3 has been ratified. So you'll see a lot of version 2, but you'll see version 3 creeping around shortly. When it talks about schemes, that's really whether you're talking HTTP or HTTPS. Host, very self-explanatory. The base path, so if you were running your application at a sub-level of your website, then your base path would change. The info section is really just some metadata that helps describe the service, but it's not really going to be used heavily by AutoRest or not a lot of the fields. So like you can just see, there's some extra data to describe what this OpenAPI spec is for. But then we start getting down into the paths, and this is where it becomes interesting. So paths are really defining the endpoints that are available in our API. So we've got a path called info.0.json, and then down a little bit further, we've got another path that takes a comic ID and then info.0.json. So in this spec, we're literally saying that we have 2 methods that are available for us to call. The other things that get defined, so we have a description of the method. So when I was talking about those HTTP methods, get, put, post, delete, we're going to do a get. We've got a description, and then the type of response. So when we're doing a get, what do you normally get when you do a HTTP get? A HTTP status code of 200. So that's all that's saying. But then the interesting piece is this schema. So this is saying that we're going to get a reference to a definitions comic. That doesn't have much information there, but we'll come back to it in a second. So if we look at the comic ID, so this is the second method. It's very similar, except it takes a parameter. And the parameter is for, the name of the parameter is called comic ID, and it takes a number. But it returns the same schema. So it's returning a definitions comic. So we're going to get the same object back. It's just going to be of the specific comic that we've asked for. So then we come down to our definitions, and it's talking about comic. So this looks like it might be referring to this bit here, and it is. And what it's doing is defining the object that we're going to get back from that REST API. So it's simply a matter of, we have a number of properties and the type of the property that it is. So OpenAPI supports a handful of basic properties that can be returned. So you've got strings, numbers, date times, and there's a few others that you can include in an API spec. And then our overall object that's going to be returned, that comic, is going to be an object that's made up of those properties. So that's the YAML version of it. We can have a look at the JSON quickly as well. Hands up, who prefers JSON? Who prefers YAML? Okay, we've got a bit of a, I think JSON's winning still, but YAML is actually a superset of JSON. So what that means is if you have a correct YAML parser, it should be able to parse your JSON no problems, not vice versa though. So you can see in the JSON document here, it's got exactly the same information, it's just formatted differently in the JSON style. So I was talking about Swagger UI previously. So this is an example from swagger.io, who provides that open source tooling. And this is a user interface that sits on top of the Swagger spec. So there's a link here where I could actually download the raw Swagger spec. But then what this does, it shows me the objects that I can modify. So essentially the endpoints of that REST API I can hit, and it shows the methods that are available. So I can do a post, a put, and a get against pet. But then I can actually drill into it, and I can look at additional information. So for pet, I can do a find by status. It has a parameter called status, which is required. We can tell by the asterisks in red. And it's an array of strings. And it has available values of available, pending, and sold. Then it actually tells me what I can get in my responses. So I can have a successful operation, or I can have a 400 if I have an issue. This API supports XML as well as JSON. I'm going to change it to JSON because that's what we're going to be working with mainly with PowerShell. So when I change it to JSON, it gives me an example of what the response is, but it also gives me the ability to try it out. So when I click on try it out, we can select available pets, and I can execute that request. So it's actually going and running against that web service, that REST API. It shows me the curl command that was run, the request URL, but then it gives me the response body. So I actually get a list back of all the pets. Okay. So that's pretty much all I wanted to cover on the API. Any questions? Okay. So in the pack, there's some more details around what the OpenAPI spec is. Also, just a summary of AutoRest straight off the GitHub. Most of the rest of the presentation is going to be demo. So hopefully by the end of this, you'll be up and running and have your own AutoRest generated module working as well. Okay, so there's a few requirements for running AutoRest. You need to have Node.js installed, and the LTS branch is the preferred branch. So you can just go search for Node.js and you can install it. There's some other utilities that you can use to install it as well. You need actually the version-free beta of AutoRest. So once you have Node installed, it includes the Node package manager. So you can run npm install -g, which means global, AutoRest at beta. So that just says, give me the beta version of AutoRest, and that'll install straight on your machine. You need PowerShell 6.1 or greater. So given 6.2 is in GA, definitely go for 6.2 or higher. You also need the .NET Core SDK 2 or greater. And that's because we're actually generating a C# project that's based on .NET Core. So you need to be able to compile that. Okay, we had a look at the APIs and we had a look at the pet store. What we're going to do is what AutoRest is doing is creating a module that's going to wrap XCD. But underneath the covers, it's still a RESTful API, so we can actually use invoke REST method and call it natively. So I'll run this command. And so that's actually gone to xcd.com, and it's returned a comic object back to me that has those properties that we saw in the spec. So that's exactly what the module is going to do as well. So it's quite a simple use case, but it's a good one to run through for learning. The second method that was available was if you specify a comic ID. So I've specified 327 here. And so if we run this command, oops, I can see I get number 327 back. So exactly what we expect. So AutoRest has some built-in help, which gives you basic syntax. So the interesting thing about the help, well, that was quite interesting to me, was the fact that it lists down these different programming languages that you could target. So you could do on C#, Go, TypeScript, you name it. So it's pretty impressive. You'll notice PowerShell's not actually in the list yet, and I think that's because it's in beta. So I'd expect to see that appearing in the list shortly. But that doesn't stop us from using it, which is lucky. Okay. So how do you run AutoRest? Well, all you need is a YAML file or a JSON file. That's the OpenAPI spec. I've already got the XKCD one downloaded, which is exactly the same as that API Gurus one that we went through. Because I've installed AutoRest, I can run this command, AutoRest, PowerShell. I pointed at the input file at my YAML file, and I've got an extra option here to clear the output folder. AutoRest is going to automatically generate a folder called generated, which is going to have all that scaffolding in that I talked about earlier. I use clear output folder all the time because as I rerun it, I want it to clear that folder every single time. So let's give this a go. Okay, that looks very promising. We saw this generated folder pop up when it ran. So if we drill down, we can see a whole heap of folders and a whole heap of files. But I like the sound of this one, how to. How to, we need more of those. So I'm going to just show you that file in preview. Oh, yeah. So that how-to markdown document actually has all the information you need to basically take the AutoRest generated stuff and convert it to your module. So what we've got at the moment is not a module that you could use. You can't actually execute a commandlet. There's no commandlets available. You haven't loaded a module. But what I can then do is I can run this build module. That compiles the C# that's used by the module. And this has some details around what happens. So it actually generates some proxy script commandlets as well. So even though it's generating a DLL, it is actually not using that DLL when you're invoking the commandlet. The commandlet is still a script commandlet, and within that script commandlet, it then makes the calls to the DLL. So we'll see that once we do with the build. There's a section around we can create some custom commandlets, and we'll see that later in the next demonstration. You can generate documentation. That sounds good. Platy PS. So hopefully quite a few people have heard that previously. It's got some commands in here. So it's got a script in here to do testing. And it's got a script in here to do packaging. So it'll generate a new get package that you can push to your PowerShell repository. And then there's some more details around the scripts. So the main one we're going to focus on for the moment is the build module. And we're going to use the run switch, which is the same as running build module and then run module. And that will generate our output. Before we actually generate it though, I did want to show you, so in each of the folders that gets created, there's a README file that's put in there, and it has some information. It says, should anything in that file be modifiable? So in the case of exports, no. Is everything generated? In this case, everything's generated, so it says all. Is this committed back into my Git repository? No. Is this packaged as part of my final module? And yes, it is in this case. So if I looked at custom, that'd be quite different. So it's modifiable, it's partially generated, it is committed into Git, and it is packaged. So it gives you an idea of how to work through AutoRest and the folders that are generated without needing too much knowledge. So jumping back to our demo, we're going to actually just build it. So the reason I specified run is because the module contains a DLL, it gets loaded by .NET. So by default, once you load a DLL into .NET, it's not easy to remove it. So what this does, it creates an isolated process. So as I'm testing and I'm going through my build and debugging cycles, I can easily exit out of this process, and I don't have any locks on my DLL. So I can recreate the DLL and then recreate my isolated process for testing. So it has now created it, so I can have a look at what we got. So our module has one commandlet that was generated automatically called get xkcdcomic. So that sounds like it's a pretty good starting point. And we can look at that particular command. So we can see here it's picked up in the synopsis, it's actually taken some of the description information that was in the OpenAPI document. We can also see here we've got two functions. So I've got an xcdcomic and xcdcomic that takes a parameter of comic ID. And that matches back to the endpoints that were available to us for that API. The other optional parameters that you see on these commandlets are defaults for AutoRest when it generates PowerShell commandlets. So they allow you to use a proxy if you need to, and there's some other commands that I'm not entirely sure what they do yet, but who knows. It's lucky we do have Garrett in the audience. So let's give this a run. Yay, so we are now calling a native PowerShell commandlet that is going off to the XCD REST API and bringing back the response from there. The other interesting thing about this, if I store that into a variable, thank you. So we can pass that into getMember. And here I can see it's a type of comic, which is what we saw in the spec. And then I can see the properties that, that were defined in the spec as well. The other advantage of that is when I am doing something like, say I was doing a select, I can do autocomplete because on the module that it was generated, it actually has a hint around what the output type is going to be. So let's just have a look at when we compiled it, what happened. So we've got here a bin. In the bin directory is a DLL. So this is actually the core DLL that the module is built on. But at the same time, under the exports folder, we got a commandlet, a script commandlet that was generated. So what does this mean? Let's have a look. So you don't need to know a lot of these details as well. That's the great thing about AutoRest. It obfuscates a lot of the details. So I was setting this up on my colleague's laptop this morning as a backup. It took me about 5 minutes to get PowerShell core installed, npm Node.js installed, and I got the YAML file down, and I was able to build that module within about 5 minutes. So you can get started very quickly without going underneath the covers, but once you work with it more, you'll need to drill in a bit more detail. So in here, we can see it has a parameter set name for get1, which takes a comic ID, which is what we expected. And then the default parameters that we're talking about that are available for any AutoRest generated commandlet. And then down here, this is where it gets a bit interesting. So we've got this mapping, and it's doing a mapping to get xkcdcomic underscore get xkcdcomic underscore get1. That's actually where it's calling back into the DLL. So that's pretty much all I wanted to show you on that particular one for the moment. but I do want to show you underneath the covers. So what we're going to do is we're going to look at system.app domain. We're going to actually use a bit of reflection to look at the assemblies, so the DLLs that are loaded in our current PowerShell session, and we're going to filter it by ones that have the XKCD in the name. So there we can actually see in this session is the DLL that we compiled and that we were looking at previously. Now, if we can drill into this a little bit further, so if we do, I want to look at what types are available within that DLL. So this is quite a long list, and there's a lot of stuff in there that we have no idea about, but there are some stuff that looks quite interesting. So I can see there's a PS commandlet of get xkcd comic underscore get, and then there's another one underscore get one. And that relates back to our script that was calling using those mappings to call those functions. The other thing I can see is there's a type comic, and that actually defines the properties that we're expecting. So the last thing that we'll look at on that object then is that actual type. So all I'm doing here is we've got all the types. I've filtered it by comic, and then I'm doing a get members, and I just format, I just want the name and the member type. And here I can see the properties that I'm seeing when the module returns. Okay. Rightio. So next, I spoke about generating a new spec file so that when you want to publish. So in our actual, in our generated code, it's already created a template for us. I'm just going to bump the versions. Also for a new spec file, it needs a few details. So we're going to put in an author. We're going to put in a license URL. We'll do the same for the project. And we can put in description. Okay, save that. And we'll jump back to our demo. One other thing I'm going to do is actually bump the module version number up to match as well. So now we can run this command. And that's actually produced a NuGet file, a NuGet package file. Who knows about NuGet? Okay, that's great. So NuGet is actually, it's just a zip file. So you can actually rename it to .zip and you can look at the contents of it. But what we can do is we can actually push this up to an Azure DevOps repository that I've got set up, and then we can install it on the machine. So I'm just going to do that push now. So this, actually that was an error. We just need to update our version to .4. So this is taking the NuGet package and it's pushing it up to an Azure DevOps NuGet repository. This could be PowerShell, it could be the PowerShell gallery, it could be your internal Artifactory repository, it doesn't matter. Okay, so that's completed. Now what I want to show you is, so this is my current user Windows PowerShell modules directory. So there's no folders in there at the moment. But what I'm going to do is launch PowerShell. And we're going to do a install. So I've already defined my Azure DevOps repository as a repository. So I can just refer it to as PS Summit 2019. I have to pass in a credential. Did anyone notice at the Lightning demos on Monday, I think it was Amber from Microsoft demonstrated a new version of package management where it could cache credentials. I don't have that new version, so I have to pass a credential every single time. And then I'm just going to install that module, so xkcd. So this is literally going to Azure DevOps, the module that we just built and that we just pushed up there. It's bringing it down onto my machine and installing it within the current user scope on PowerShell, Windows PowerShell. So So this shouldn't take too long because it's not a very big module. Okay, great. Okay. So what do we got? So we look up here. So all those folders that are generated as part of AutoRest, this is all we ended up with as part of the module. So we're going to quickly drill into a few of those. So I think I can do this another way as well. So here's our private DLL that we were talking about previously. In custom, we'll see this later, this is where you can put custom functions and custom code that you want AutoRest to pick up. Exports, this is the script commandlet that wraps the DLL that we saw previously. Internal is if you had internal functions that were that you didn't want exported outside your module. And then you have a formats file, your module definition, and your module file. So all the normal things that you expect to have. So we should be able to run another commandlet. So let's just run. We'll run this one. So all we're doing is get XCD comic. The comic ID is 327. Oops. Duplicated there. Image is a property that has a URL to the actual image, and we're saying start process. So that's actually gone out to XCD comic, got back that metadata that we get, and then it's loaded the comic. Okay. Rightio, that's my only attempt at humour, so it's all over. That's the end of the XKCD part of the demonstration. I now want to talk about my experience when we're trying to compile against our own API. I'll just clear up a bit of this so you can see a bit better. So what we've got is I've got an app running locally, an instance of my application for my company that's running locally. And so we use, it's built on ASP.NET, and so it's an ASP.NET core application, and we use a package called Swashbuckle, which automatically generates our OpenAPI doc for us, and it also embeds the Swagger UI into our application for us. So in the same way that we were looking at the pet store previously, this is actually our application. We're looking at the endpoints and the spec that's available for our app. So I can click on this link and I can get a full copy of the spec from our site, but we're going to focus on this AD domains. I don't know whether it's just coincidence, but it's the first one on the list, so that's pretty lucky. So once again, we can look at parameters and we can look at responses. So in our spec, we don't actually have any parameters, and the response is an array of domains. So that's all we really need to know about our app, other than our app requires authentication. So this was my first real hurdle when I tried to compile or get AutoRest to build against our spec. So I've got a copy of my spec here. So I downloaded my spec. I had to change the version. We weren't using semver for our version, and AutoRest expects the version to be in a semver format. So that was simply a matter of making it 1 ... something like that. So 1.0, and I had to change my host address and point it to my local URL. Other than that, the API was fine. I could actually get AutoRest to generate all that output and generate the module, but when I tried to use the module, it came back unfortunate with I need to be authenticated. So I'm going to run a tool called Fiddler. Has everyone used Fiddler or had exposure to Fiddler? So what Fiddler is a HTTP proxy that allows you to capture all the HTTP traffic going through your machine. So it's very useful for troubleshooting anything related to HTTP. So I want to be able to look at the HTTP headers that are leaving my machine, going to my local website, and what I was getting back. So we're just going to leave that running in the background while we move on. Okay, so we don't need our Swagger anymore. So what I do have under here let's close that. So now under that generated folder, I have a custom folder and I've placed a file in there called module.cs. In the AutoRest documentation, there's a sample for to search the times API. It has an example of adding an API key into your request URL. I've taken that and I've modified it so that I can do Windows authentication to my local machine, OAuth authentication to Azure, because we run our site in Azure as well, and you can do basic authentication, or you can add an API key. This is all very much just proof of concept type of code so that I could do the demos, but it'll give you some ideas. So what I've got in here is, let's have a look, module. So this is a C# class and allows you to extend AutoRest and customize AutoRest beyond what it does out of the box. So for your normal circumstances, you may never need to use this. It depends how deep you need to go. So I've got a namespace that I've named the same as our app, glue.api. And then the interesting parts are around this partial void custom init. This is sort of the entry point where you can do your customization. So I do some cheating that I sort of got from the sample where I read some environment variables. So if there's an environment variable set called negotiate auth, I will actually set up Windows authentication. Now, the difference between Windows authentication, basic authentication, and OAuth authentication is Windows authentication actually has to be configured at the time you're instantiating your HTTP client. Whereas when you're doing OAuth or basic authentication, you're just adding a header to the request. So you're adding an authorization header, which will either have basic and then your base64 encoded, or bearer and your OAuth token. So by doing this, I check if I want to use Windows authentication. I then create a credentials cache. But at the end of the day, all I'm really doing is I'm creating a new instance. I'm creating a new instance of a HTTP client where I'm passing my credentials in and I'm telling the type of authentication I want. So I'm passing in negotiate and I'm passing in my default network credentials. So really, when it comes to AutoRest, this is a particular use case around customizing for authentication, but you could be doing other things as well. The way AutoRest has been built is so that you can use it with a proxy or without a proxy, and one of the requirements for that was actually to instantiate a pipeline for the case when you're not using a proxy and also when you're using a proxy, so that's why you see the line sort of repeated. If I don't want to use negotiate authentication, then what I'm actually doing is I'm adding I'm calling a function that adds a response, a header onto my request. So here I'm going append add auth, which is calling this function down here add auth, and this is doing some cheating again. It looks at local environment variables. If it sees OAuth header as an environment variable, it's just going to add a request header to every single request I make with that bearer and the OAuth token. And then that's repeated for basic header and similar for API key. So that's all we're going to cover there. You don't need any more information. Let's get rid of that. The other thing I can do in the custom folder is I can put, I can create, I can create any commandlets that I want. So if I've got other commandlets that I want AutoRest to pick up, I can put them into this folder. So I've added another commandlet here called connect glue, and this actually goes and does my authentication Azure to get my, my OAuth token that I can then use for subsequent calls. So it's making a invoke REST method to the Microsoft OAuth server, and then it sets the environment variable for OAuth header with that token. So, okay, so let's build this and see what happens. Demo. So I'm going to set it to, I'm going to set the environment variable for local, for Windows authentication. Oops, that's not going to work because we're in the wrong folder. So let's change folders. Oops. Okay, that's better. So let's run that again. So it's the same format. I'm using PowerShell extension for AutoRest. I'm just passing it the swagger.json, which is the OpenAPI definition for our application. I'm using clear output folder again, but I have one difference here where I'm specifying the namespace as glue.api. And that's because I'm using that custom C# class that I've written, and the namespace for that is glue.api. So it just allows AutoRest to be able to pick it up. This API is a lot bigger than the XKCD, so it takes a bit more time. I did find running it within VS Code is a bit slower than what it was running it natively through PowerShell core. So in a moment, hopefully that will finish. So we'll just clear our fiddler output. Progressing, that's a good sign. We're not dead yet. Okay, so let's build it. So you can see here, if I refresh, sorry about this. So under my Glue demo, I've got it generated. I've got all the same folders and similar files to what I had when we did the XKCD example. So we're going to do it's compiling our module, and in a moment we should be able to run a command. So if we have a look at get command, we pointed out that module. Oops. Yeah, that's not actually true. So let's, it didn't generate that many commands. Let's fix that. Glue API. But it has generated quite a few. So, so we're going to use that get AD domain. So that's, I haven't delved into it in full detail, but I think it's issues with our OpenAPI spec from our application. So it doesn't know how to define those. So get AD domain, it's returned the data. And if I look back at Fiddler, I can actually see my Windows authentication negotiation hand sequence that happened. So you can see originally there was no request, there was no header, and then we've got a negotiate header, and then our successful response. So if I hadn't created that custom code, you wouldn't have any headers, no negotiation would have happened, and I would have got it, authentication denied. We're running out of time, so I'll just quickly cover a couple of items. So you can actually define all the configuration for AutoRest in a Markdown file. I hadn't come across this previously, but it's called a literate configuration file. So you can actually mix documentation and your configuration together in a README file. So I do have a quick example. So this file here has documentation about the Glue API, but then down the bottom it has these YAML sections where it specifies the JSON file, the namespace, clear output, and to use this. And so I don't need to specify anything else other than running AutoRest. It'll by default pick up a readme.md in the current directory and look for those code segments to configure it. And then finally, so you can use AutoRest, as I said, to target any other of those supported client libraries that you might want to. So I tested it out with XKCD and it piped it to a Python library and it generated no problems. So any of the ones that are listed in the help, you should be fine to do. So I just had some final thoughts. So AutoRest is an absolute great way to generate PowerShell modules for RESTful APIs from the OpenAPI spec. But you need to be a little bit careful. Auto code generation has limitations. So you need to be looking at making sure that the commandlet names, the parameter names make sense. You need to be looking at what sort of pipeline support you want to do. Is it usable to the end user? Because it's all great creating all these commandlets, but if it's a nightmare to use, it's really not going to serve the purpose that it should. There's plenty of extensibility options, and I certainly haven't explored near a small portion of them today. So if you do want to do more of this, drill in. The README documentation's great. It's being updated all the time, so the team's really actively working on it. If you're building your own REST API, one of the big benefits is the fact that you can target those multiple SDKs. So with the same amount of effort or similar amount of effort, you could be generating for PowerShell, for Python. I don't know why people think Python's so popular. I don't know. Anyhow. So a big call out to Garrett. He's the primary developer. Very responsive on Twitter and very helpful as I went through the process of producing this presentation today. He's got a great blog that he published back in February that covers off some of the details of getting started, and it's got a link to the XKCD. There's a link to the AutoRest PowerShell repo and also the AutoRest repository, and directly to the XKCD demo so that you can try it yourselves. Big thank you. I appreciate all your time. Any questions quickly? Thank you.